Here's a really good one. Question 9 from 17.11. It's got a polynomial, a quadratic, and it says this is a perfect square. And we've got to find out the values of s that would make this into a perfect square. So in other words, it equals 0. Now, if it's going to be a perfect square, then it's not just that this equals 0. I mean, all functions are going to equal 0 if we're going to solve them. But it means that the discriminant has to equal 0 because it's going to touch the x-axis. So in other words, it's going to be something that looks like there. That's a terrible that's a terrible parabola. But you get the idea. Here's my x, here's my y. It's going to look like that, or on the other side, that's what we're looking at, yeah? So that's what we're after, something that looks like that. Of course, we're looking for the values of s that would make that true. We're not going to calculate that. Although at the end, if we get time, we will. Depends how much video we got left. All right, so let's have a shot at it and see how we go. So first of all, we know it's perfect squares, so it must be equal to 0. That is the discriminant must be equal to 0. So here it is, must be equal to 0. B, well, where's B? B is all of this here. So it's going to be equal to negative s minus 2. Yeah, and it's all of that squared. Yeah, that's not a very good square, is it? Minus 4 times a, and a is s plus 1, times c, which is 1, and that must equal 0. All right, this is not very good, is it? Let's just change this around. So you've got negative s plus 2, or if you like, 2 minus s squared. That's a better way of writing that. Minus, well, negative 4 times s is going to be 4s, and negative 4 times 1 is going to be negative 4, equals 0. Okay, so let's see what we can do with this thing on the side. I think we're going to have to expand that out. So we're going to have 2 minus s, 2 minus s, minus 4s minus 4 is 0. 2 2's are 4. Negative s times s is plus s squared, and negative 2 times s, negative 2 times s is going to be minus 4s. And we've got a minus 4s as well, and a 4, a 0. And of course, 4 and negative 4 just cancels immediately. That's 0. So we're left with s squared minus, you've got 4s, 8s is equal to 0. So we can factorize that. We can go ahead and say, well, s times s minus 8 is 0. Therefore, s equals 0, or s minus 8 is 0. When I say s minus 8 is 0, I mean if I added 8 to both sides, s would equal to be 8. So here's my solutions. I've got a solution of s is 0 and a solution of s minus 8 is 0. So what does that actually mean for the actual polynomial? Well, let's just actually take a bit of a sidebar here and see if we can actually turn this thing into a perfect square. So let's have a look at it. So we've got, and I'll restate it now, so it's going to be, it's s plus 1 x squared minus s minus 2 x plus 1. And that equals 0. I haven't got much room here. I've got equals 0. That's squeezed in there, yeah? But let's make x, well, we've got two things. We can make it equal to 0. Let's make it equal to 0 first. Here we go. So I'm going to make this equal to 0, so it's going to be, that's 0, so it's going to be 1x or x squared. So x squared minus, this is going to be 0, so it's going to be 0 minus 2. And negative 2 is going to be plus 2x plus 1 equals 0. So let's have a look what x would have to be. Well, factors of 1 are 1 times 1. So it's going to be x plus 1 squared is equal to 0. And there's my perfect square. Well, let's look at it with an 8 in there. So I've got an 8 here for the s. So it's going to be 8 plus 1, or x squared, minus 8 minus 2x plus 1 is equal to 0. That wasn't very well written. I'm sorry about that. 8 plus 1 is 9x squared minus, well, this is going to be 6x plus 1 equals 0. So that actually is a perfect square. I can see it right now because it's going to be 9 times 1 is 9. We're going to have 9x. Factors of 9 are 3 and 3, which will be -3 and -3. So we can see it right here. Of course, I can divide all that by 3 and that by 3. So it's going to be x minus, it's going to be 3x minus 1 all squared equals 0. So here again is another perfect square. So we've got a perfect square here and a perfect square here by using the two values that we got with 0 and 8. Now, you didn't have to do any of that, but what was interesting to see is we were told it was a perfect square if we got the right values for s. We found the values that we thought would be right for s, which we did, which was 0 and 8. And lo and behold, when we put a 0 into here, that was with x, that was with s equals 0. That was the thing we tried. And here was, in this one, we had s equals 8. There was the thing we tried. And lo and behold, it worked out. And we had a perfect square here and another perfect square here.